Hello, today we're going to talk about topic 4, section 2, presentation of data. Okay, so imagine you are wanting to count the number of grapes in a vineyard. So you get a sample of some bunches and you count how many grapes are in each bunch. Okay, so this is all the data. This is not helpful. Showing people a list of a random assortment of numbers is useless. A picture is worth 1,000 words, and that is so true in statistics. You need to be able to organize your data so people can follow it. All right? Because in an ideal world, you would have a whole lot of data, and you would not want to put that in a table like this or a list like this. You'd want to put it in a picture, an easy to read picture. So, what do those pictures look like? Well, we can organize our data. First, we're counting, so we're getting several numbers that are repeated, so we can tally them and make a frequency table. Okay, this only, of course, works when you're counting things. So here you have a frequency table with each individual bunch that you've collected, and then here we've grouped them based on like sections. 1 to 3 bunches, 4 to 6 bunches, and kind of condensed our frequency table. Then you can make a diagram. Okay. Again, this is very important. This was with what kind of data? Discrete data. Super duper important. Okay. So that's when you would use a frequency diagram. Okay, you can also have a frequency table with data that looks like this. Notice these are the heights. All right, notice anything interesting about these values? All right, you should notice that they pick up where they left off. Okay, so it's all the numbers in between. So this is not your counting data. This one is with your continuous data. Woohoo! All right, so with continuous data, you would use something called a histogram. So it's very similar to the last one, but notice the bars, those rectangles, they touch because they pick up where they left off. It's all the values in between. On this one, with discrete data, the bars do not touch. Okay? Make sure you choose the correct one. Okay? It's important to make that distinction. Okay, so we can also do a cumulative frequency table. So if we want to know if how much something is growing over time, so kind of like investments are big on this. You want to look at your money adding up over time. So here we have our frequency table, and then the cumulative frequency would just be all the values ahead of it. So on the second value, we added the one before it, 8 plus 3. Then the next one, we added the values before it, 8 plus 3 plus 6. Then we add the 12 in, right? So it's growing over time, okay? When we group our data into this frequency tables and graphs, all right, it's very important to know how to, what these values mean, what this vocab is. So think about what it says, mid-interval values. Well, look at your intervals, and what are the mid values? So the mid value between 149.5 and 152.5 is 151. The value between 152.5 and 155.5 is 154. Okay, so these are all the values that are in the middle of our intervals. Okay, interval width. Each interval has the same width. They're all 3 centimeters because that's height. Your lower interval boundary, well, look at your interval. The boundary goes from 149.5 to 152.5. So the lower one is 149.5. What? Okay, so that's a typo. Because all the lower interval boundaries, they're all equal to this left side. So they should all be this left-hand side. So, yeah, 152, 55, 58, 60. Yeah, see, that's got to be a typo. So 49.5. There we go. Yeah, and I know I just gave all the answers away. That's all right. So then let's see the upper interval boundary. Okay, so it looks like it would be 152.5 all of the right hand side, but these are not equal to. So that interval isn't actually equal to it. So what I did is I put all of them as 0.4. Actually, I should have specified to 1 decimal place. Oop, if I can write to 1 decimal place. Okay. Sorry about that. All right. And then the last one is the modal class. All right. So modal, think about the root word there. Mode. It's not model. I know it looks like that, but that would be spelled with an E, right? We're in math class. So modal class. All right. 12 is our highest frequency. So that would be our biggest interval. 159 to 161. What? I guess they rounded? I would have put 158.5 to 161.5, but whatever. Okay, let's see. So hopefully that makes sense. Those are your kind of most common graphs. All right, another big one is having to do with quartiles. Okay, so knowing your quartiles. That's when I split the data into kind of percentages. I split it in half, then I split it in half again, and I've got 25%, 25%, like I'm splitting it up between 4 people. Okay? So make sure you know this information. Okay? Notice how they did certain things as well. Okay? They went and found the median by, you split it in half. Literally 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We're left with 2 in the middle. So halfway in between is 25.5. That's how they got the median. Then to get the quartiles, okay, what we would do is actually, this is debatable. Sometimes when you pick, well, hold on. Let me see. I'm trying to remember what Cognitive said. All right. Okay, so what Cognitive says is if the median is split between 2 values, you don't throw it out. So then, to find the quartiles, you would include that 26 with the right side and that 25 with the left side. So over here, when I split this in half, I get 33. When I split this in half, I get 16 in the middle. Okay? If the median was 1 value, let's say 25 wasn't there and 26 was the median, you would not use it on the left or right side. It would get thrown out as well. Then you would find the median with the leftover data on the left side. So if the median is 1 value, throw it out, then find the median, all right, of the right side, median of the left side. That's what these are. Median of left data. And this is, think of this as the median of right data. Okay, so if the median is 1 value, you throw it out, find the medians over here. If the median is 2 values, keep it and leave them 1 on the left, 1 on the right. Okay? All right, let's keep working on quartiles. Okay, so here we're going to use this data in a frequency table and find the 5-number summary and the IQR. So here's the values, here's how frequent they are, and notice I've listed them out. We have a 2 that happens 4 times, 4 that happens 7 times, 6 happens 8 times, 7 happens 5, 10 happens 2. So now let's find the median. Okay, so we just split it in half. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just guessing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We need some more. 1, 2, 1, 2. All right, so we've got two values for the median. All right, so we split it in half, find the middle, and it's still 6. Okay? So now we can find the other ones. So let's find the median of the left side. So now we include, all right, these 6s. So now we're splitting it in half. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 1. Here is the median of the left side. That would be called Q1. Split it over here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1 and 1. Here is the median of the right side, so that is Q3. Okay? And then our lowest value would be called the minimum, and the highest value would be called the maximum. So let's see how we did. All right, minimum is 2. Q1 is 4. Median is 6. Q3 is 7. Max is 10. Looks like we did good. Now, what's left is the IQR, which is the inner quartile range. So the inner quartile range, let me write that out for you. So the interquartile range is literally the range of the inner quartile, the inner half. So Q3 minus Q1. So 7 minus 4 is 3. So there's the 5-number summary plus the IQR, the interquartile range. All right. Let's keep going. We'll come back to this spot in just a minute. All right, so now we need to talk about quartiles or box plots. Okay. It's important that you know how to draw a box plot. Okay. We have the minimum is the spot over here. The maximum is over here. Q1 is this spot, this dot. Oh, I'm sorry, Q1. And Q3 is this spot. And then this middle, this line here, is the median. All right. The box plots can look different every time. The median is not always right in the middle of Q1, Q3. Notice this is a little closer to Q3. It just depends on how your data is spread out. Okay, make sure you know how to draw this out. So draw it out for this one. Let's go back a few slides. Okay, now you have this information. Draw your box plot. All right, you do that, you should get something like this. Here I have it with tick marks so you can see how it's spread out. You want to make sure that it's correctly spaced. You know, you don't want to put, for instance, the minimum here, then have this part here, and then your maximum here. This is not a box plot of this data. All right, you can see that they're kind of evenly spaced, and we do not have that represented here. So you always want to make sure that you draw it to scale, right, or best you can. All right, what about for this example? Take a minute, draw this one. Now you have this information, draw your box plot. See what it would look like. Okay, hopefully you got something that looks like this. Okay, again, I know it looks like the median is still kind of lingering towards the right. That's not always the case. It just happens to be how our data is spread out. Okay, all right, so quartiles, super important. I'm so silly. I just realized that this one is the same one as this information. I don't know what I'm thinking. I guess I put this together and didn't quite realize. All right, but I do have this calculator symbol here. So let me show you how to use your calculator. So first, let's go to our calculator. Turn it on. You want to go to Stat, then hit Edit. So this is where you're going to put in your lists. So here we're going to put in our values for the left side. So 2, 4, 6, 7, 10. Then we're going to put our frequency on the right hand side. So 4, 7, 8, 5, and 2. Then I'm going to quit this. I'm going to go to my, well, first I'm going to make sure my equations are cleared. Oh, yep, got to clear those. Then I'm going to go to my stat plot. So second y equals. I'm going to go to the first one. I'm going to turn that one on. So I want to make sure I hit enter and make sure the on is the one that's shaded. Then I'm going to select the box and whiskers plot. Always pick the one with outliers. All right, you always want to make sure that is shown. Why is it letting me pick that? Oh, I have to go to the right. Okay, weird, different calculator than the one I have at home. All right, so pick the one with outliers. And so list 1. And here, since we used a frequency table, we're going to say frequency is list 2. So then you're going to hit, what is it, second trace? Nope, that's wrong. Go back here. All right, so I can just hit, where is it, second, and then the number 2 for L2. Okay, list 2 is my frequency. And then it doesn't matter which mark you use. Then I hit zoom. What is going on? Zoom. Very weird. Zoom stat, so number 9. And that's going to zoom in on my box plot. And there it is. So if I trace it, I get the minimum is 2. Hit right. Tells me Q1 is 4. Median is 6. Q3 is 7. Max is 10. So everything I did was correct. So that's how you can do it on your graphing calculator. Very useful thing to know. All right. Knowing how to interpret knowing how to interpret a box plot is super duper important. Okay, you've got your it tells you everything you need to know about your data, how the spread of the data looks. Okay, in a perfect world, we would have all even quartiles. Okay, evenly spread out, the median directly in the middle. We'd have kind of this bell curve. Everything is 50-50. It's normal, perfect. Okay. However, the world is not like this, okay? Usually something's skewed, okay? If we see there is a whisker is a little bit longer on the right-hand side, that means that this is skewed to the right. There is data on this right-hand side that's pulling it further out, okay? Left skewed is when the data is on the left-hand side, pulling it away from the rest of the data. People mix these up all the time. Don't do that. Know these, okay? Put that on your flashcards, okay? Know the difference between what a right skewed and left skewed, positively skewed, negatively skewed data box plot looks like, okay? Outliers. Outliers are not how it looks. I can zoom in or zoom out and make data look like everything is perfect or everything's an outlier, okay? So don't go off what it looks like, okay? So you need a reason. How we get our outlier, okay, is we use this little formula, okay? So it's easier to do than, I don't know, just memorize, right? So I like to visualize. When we're drawing our whiskers, okay, the whiskers only go out to the lower limit and upper limit, not necessarily to your minimum and maximum. Your min might be out here, all right, but that's an outlier, all right? You would not draw your whisker all the way out here. Not going to happen. Your whisker only goes to the lower limit, okay? So how do you know what that lower limit is? That's with the outlier formula, okay? So we have our inner quartile range. From here, we can only go out as far as 1.5 times that distance. Okay, and that would be considered normal, within normal range. Okay, So your lower limit is the furthest the whisker can go to the left, and it's your Q1 minus that 1.5 distance. Over here, this would be considered your upper limit, the furthest that the whisker can go to the right, so you would take Q3 plus that distance. Okay, I don't usually think about it in a formula like this. I like to think of it as, you know, just knowing that it's 1.5 as long as that middle part. Okay. All right, so we've got a box and whisker diagram drawn. So estimate the number of nights that the student sleeps less than 5 hours. Okay, so if they're going to sleep less than 5 hours, that's right here. Okay, that's for this problem. All right, we want to be everything down here. Well, notice that is from our min Q1, and that represents 25% of the data. Okay. Let's see example 2. Number of nights the student sleeps at least 5 hours. So they could sleep more. So that's on this part. Okay, so they can sleep anywhere from 5 to 11 hours. Well, if that's 25%, remember this is 25, this is 25, and this is 25. So this represents 75%. Example 3. The number of nights that a student sleeps between 2 and 6.5 hours. Well, 2 would be here. 6.5 would be from here. So we want this percentage. That represents 50% of my data, from my minimum to my median. Okay, see, we can figure out percentages with a box plot. There's so much more we can know. I mean, obviously we can't do it from 2 to 3 hours or from, 4 to 9 hours, but if we are just looking for the min to Q1, that tells us a lot, okay, about where our data is spread out. All right, again, a cumulative frequency curve. Okay, so we should know how to get a cumulative frequency table. You just add up the ones ahead of it, okay, and you're seeing the data as it grows. So you can first make a polygon, which is where you make your boxes. Okay, you just draw your regular histogram, and then here you would just draw the diagonals. So that blue line right here where it's kind of like jagged, that's your cumulative frequency polygon. Okay, then the cumulative frequency curve is they're connected by a smooth curve. So that's when usually we use a graphing calculator so to kind of estimate what that curve would be. Okay, and then here we can get our box plot from this data too, because you can see where the Q1 median Q3, because that would be where just where they plotted the data. You couldn't infer anything from that. Yeah. Okay. All right, let's do another example. So take a second to read this. All right, so for the first example, we're going to, we want to find the median percentage of copper ore in the samples. Well, the median percentage comes from the middle sample. So we have 40 samples. So where is the middle 20 samples? And that would be right here. And so we would have, what is that? A little over 40. How did they write their answer? 44. There you go. Okay, so you're estimating here, you're looking for the middle half the samples. Okay, so half samples is 20. Okay, so that's what we were looking for right here. All right, next one. So for this one, we want to identify the interquartile range. All right, so again, we have 40 samples. So from the, how should I put this? You have from your minimum to Q1, to your median, Q3, and your max. So in here, we have 10 samples. From here, we have 10 samples, 10 samples, 10 samples. Okay? And what we want to do is the interquartile range. So from here to here. So we want from 10 samples to 30 samples. So from 10 samples to 30 samples. So we're looking at the values here. So when we draw this line, I believe that's 20, yeah, these go up by 4. And then this one, which is 80. All right, so the interquartile range here would be 80. Maybe I should draw that a little further over. So 80 minus 28, which should give us 52. Let's see if I'm right. Bam! Okay. All right, hopefully this is making sense. All right, let me circle my answers. I know I need to do that. Make it easier to find. All right, so let's do example 3 now. So for this one, we want at least 75% of the samples must contain more than 20% ore. So 20% is right here. We want 20% or more, anything over here. So if we're at 20%, we're going to be roughly around 6 samples. So 6 samples is when I start to see an increase in percentage of ore. So that means I have 40 minus 6, so 34 samples that have 20% ore. Okay, so the percentage of samples containing that would then be 34 over 40, which is a percentage, let's see, hopefully this is right, 85%. Yes, because that would be 0.85. Perfect. All right. Again, if this is not making sense, please ask me in class. You are not alone. Stat gets super duper confusing. Okay? So I'm starting you off slow, but if it starts getting overwhelming, just holler at me, all right? Okay, I'll see you in class.